this is where we left off yesterday. We did that part together, and then I told you to write in the transformations. How many transformations do we have here? 2. That first one is a reflection in y, and then the second one means we go up 3, right? Okay, so where is the asymptote for this function? X equals 0. Very good. Now always have it as an equation because it's a line. All right, so then we're going to use our anchor points that we found and go through this process. So I'm going to start at 2, -1. I reflect in y, so I end up over here. Then I go up 1, 2, 3. Then I'm going to be at 1, 0. I'm going to reflect in y and go up 1, 2, 3. Then I'm going to be at 1/2, 1. I'm going to reflect in y and go up 1, 2, 3. So I'm here. Something like that. Okay. All right, so my domain going from -infinity to 0, but I don't include any of them. Range, -infinity to infinity. Do I have an x-intercept? Yes. Do I know exactly what it is? No. I mean, mine looks like it goes perfectly to that point, but chances are really good it's anything but that. So we'll come back to that. Let's go ahead and do the rest. We already did the asymptotes at x equals 0. As x goes to the right, as it approaches 0 from the left, f of x approaches infinity. And then as x approaches -infinity, f of x approaches -infinity, right? So I have to go find where my x-intercept actually is. And I have my x-intercept when y is 0. So that means I'm going to have 0 equals log base 1/2 of -x plus 3. So I can't rewrite it until this is isolated, so I need to subtract 3. So I get -3 equals log base 1/2 of -x. Now I can rewrite it, and I can have 1/2 to the -3 power equals -x. What's 1/2 to the -3 power? 8. So this gives me 8 equals -x, so x equals -8. It's -8, 0. I think mine goes through -7, 0, but we didn't know what it was. It's fine. If yours, should be close to it anyway. It should make sense to be close. All right, what questions we got? We good? All right, let's do one with a natural log. So I need to write my parent function, which would be y equals the natural log of x. When I rewrite that as an exponential, what's the base? E. So I would have e to the y power equals x. Then I need my anchor points. So I'm choosing y to be -1, 0, and 1. E to the -1 power, that's 1 over e. It's about 3.7, 3.8. I'm sorry, not 3.7. 0.37 or 0.37, 0.38, but we can just estimate it as 0.4. Good enough on here because it's going to look like 0.5 anyway, most likely. Then e to the 0 power is 1. E to the first power is about 2.7. A little less than 3 is all that really matters when you're estimating on the graph. Then our transformations, the 3 is a vertical stretch by 3, and the 1 means we go down 1. So where is my asymptote? X equals 0 still, right? Because we didn't go left or right anywhere. So asymptote, x equals 0. Now I'll use my anchor points. So I go to 0.4, -1, right here. Vertical stretch by 3, that becomes -3. Then I go down 1, right about there. Then 1, 0. Vertical stretch by 3 doesn't go anywhere, and then I go down 1. Then about 2.71. Vertical stretch by 3 gets me to 3. Then I go down 1. It's about right here. So that's what I've got. Domain, 0 to infinity. Range, negative infinity to infinity. I have an x-intercept, but I don't know exactly what it is, and I don't get to guess off the graph, so I'm going to come back to that. Then as x approaches infinity, f of x approaches infinity. As x approaches 0 from the right this time, f of x approaches negative infinity. So to find my x-intercept, I'm going to have 0 equals 3 times the natural log of x minus 1. Got to get the natural log by itself in order to rewrite. So I'm going to have to add 1 and divide by 3. So this will give me 1/3 equals the natural log of x. When I rewrite that, the base is e to the 1/3 power equals x. Now, off the top of my head, I don't know what that, I know e is about 2.7, but the cube root of that, I don't know what that is. So I would say it's probably about a little bit more than 1, right? It doesn't matter what it is, but you can tell by your graph, oh, it's a little bit more than 1. And this is, but I just have write it as e to the 1/3 power. I don't really care what it is. What questions you got? All righty. Let's move on to what we're actually doing today, which is solving exponentials using common bases, which most of these steps we've pretty much already done in the other, getting to know logs and exponentials. So here are steps to solve. We rewrite the equation using a common base, okay, which we've already kind of done that. That was probably something that was on your quiz today. Use the properties of exponents to simplify each side of the equation. We've done that. And then use the one-to-one property, but we haven't really talked about what that means. So the one-to-one property is what actually allows us to solve it. If we have b to the x equals b to the y, then x has to equal y. That should be painfully obvious. Like, what else could it be, right? But that's the rule that allows you to actually just take it out of the exponent. And then it also, we can also show that that works with logs, but we'll get that, we'll look at that a little bit later. And then we solve it. So we're not doing all of these, but I think your numbers do match mine, where last periods didn't. So we're going to start with number 2. So I have, but on my board, these exponents just look like blobs. These already have common bases. My common base is e. So if the two bases are the same, then whatever the exponents have to be equal as well. So this is just 4n my, no, that's not, is that a w? Oh, just a blob up here. 4w minus 1 equals 5 minus 2w. Then it's just a simple equation that you learned how to solve before you ever took algebra. So I'll add 2w to both sides. This is 6w equals 6, w equals 1. All right, number 4 we're going to jump to. So we don't already have a common base. We need to get a common base, which again is something that we kind of already did. It just wasn't set up as an equation for us. We set it up like that kind of. So I could use, what do you want to use as your common base? We're on number 4. Oh, okay. It's okay. I was like 9. Okay, yeah, I would go with 4. Or I mean, you could go with 1/4, but I think 4 is probably what most of y'all would do. So 4, and then that would be to the negative what? Third. So that equals 4 to the a squared minus 4 power. Now that you have the common bases, now they get to come out of the exponent. Negative 3 equals a squared minus 4. So 1 equals a squared. What is a equal? If you say 1, my head might explode. Plus or minus 1. if you take the square root, you have to put in a plus or minus. Okay, we good? All right, let's look at number 5. I think 2 would make the most sense as my common base, right? So 2 to the m minus 9 power equals 2. 2 to what is 32? 5. So 2, 4, 8, 16, 32. It's 5. So I have this 5, but then I still have that m plus 3. So make sure that's in parentheses there. Now that you have your common bases, now that it gets to come out of the exponent, and you get m minus 9 equals, I'm going to go ahead and distribute as I rewrite it, 5m plus 15. So if I subtract m from both sides, I'll get 4m. Subtract 15 from both sides, I'll get negative 24. And m equals negative 6. You have to have common bases before they come out of the exponent. So even if you know this is what it's going to look like by looking at this, nobody cares. You have to do this part right here to get the common base to use the rule that allows you to do it. Okay? All right, let's look at number 6. Can I use 49 as my base? No, because 49 times 49, I don't know what it is, but it's not 343. With 49, I don't have that many options. 7's the only other option, right? So I'm thinking 7's probably going to have to work for 343. And then 7 times 49 is 343, so that works. So we'll do 7. 7 to what would give me 343? Third. And then, so that's 3 times 2n minus 4 equals 7. That's going to be to the negative 2 times n plus 4. Now that I have my common bases, I can take the exponents out. I'm going to go ahead and distribute as I do that, and I get 6n minus 12 equals negative 2n minus 8. So I'll add 2 to both sides, so I get 8n equals 4. So n equals 1/2. We good? Awesome. Let's see, we are going to do number 7, but number 7 we're missing a fraction bar. It disappeared somewhere, or at least I am. I don't know if you are, but okay. So I could make my base 4 or even 2, but there's nothing wrong with leaving it as a fraction. If one's a fraction and one's not, I can understand wanting to put it as a whole number, and that's fine. But here I think we're just going to leave it as 1/4. There's no reason not to. So this first one is just 1/4 times 2k squared minus 6. No, that's an x, not a k. Sorry, it looks like a k up here. 2x squared minus 6 equals, so this would be 1/4. 1/4 to what power gives me 1/64? Third. So this gives me 2x squared minus 5 in there. So then I would have 2x squared minus 6 equals 6x squared minus 15. So I have squareds, and when I subtract, they're not going to zero out. So that means I'm going to have a quadratic, which means I want it set equal to 0. So I think I'll move everything over to the right to keep my x squared positive. So I have 0 equals 4x squared minus 9. Can I factor that? Yes, it is a difference of squares. So this gives me 2x plus 3 times 2x minus 3, whoops, which means x is plus or minus 3x. Okay, what questions you got? Alrighty, we're going to skip number 8. You do number 9. Okay, what questions you got? We good on that? Okay. All right, so let's look at number 10. I don't think I can use 64 as my base, right? So with 64, I've got other options. I could use 8, 4, 2. Those are all fine. So probably the bigger the number, the better. Could I use 8 as my base here? 8 times 8 is 64. Is 64 times 8 going to give me 512? Yes, it does. So we can use 8. So I will have 8 to the 3 times 2y squared equals 8 to the negative 2 times 3y plus 5y squared. So 6y squared equals negative 6y minus 10y squared. Once again, I have a quadratic. Things are not going to zero out, so I want it set equal to 0. This time I'm moving everything to the left, so my y squared stays positive. And I will get 16y squared plus 6y equals 0. Can I factor that? Factor out a y. 2y. Okay, so I can factor out the 2y. So 2y leaves me with 8y plus 3. So there you go. That's factored. So my y, I'm going to have more than 1, so I need my squigglies. Negative 3/8 and 0. Okay. Any questions at all? Alrighty, let's look at 11. So 11, I have common bases, but I have more than 1 on the left, and you can only have 1 on each side because there's just b to the x, b to the y. So I am multiplying 2 terms that have the same base. What do I do with the exponents? If I have x squared times x cubed, what is my answer? Add them. It's x to the 5th. When you're unsure of what to do, think about something you totally know. The rule is the same. So I add them, which means this becomes 5 to the c minus 1 plus 3c plus 2 equals 5 to the 7c plus 16 power. Okay? Then I can go ahead and take them out of the exponent. I'll condense this as I do that. So this gives me 4c plus 1 equals 7c plus 16. So then if I subtract 4c from both sides, this gives me 3c, negative 15, c equals negative 5. And a reminder again that you cannot skip this step. Even when you look at that and you're like, oh, I already have common bases. All I have to do is add them together. You still can't jump to this step because you have to use that rule. Okay? You got a question? You good? Oh. Yeah, okay. All right, so same thing here. I've got 2 on each side though, so I'm going to have 8 to something and 8 to something, and I just add them. So this is k squared plus k plus 2k minus 9 equals 8 to the 4k plus 11 power. All right, you finished that one up. What questions you got? Okay, so I want to show you one other thing that is not really necessarily 100% related to this as far as what we're trying to solve, but just like when you multiply them, you add them together. If they're added together, you could split them apart, okay? And that's something that you're going to have to be able to do in calculus, especially with e. So let's say that we have e to the 3x plus c power. Because you'll have a lot of plus c stuff, and that's just some constant. Because a lot of times you don't care about what your constant is, it's just some number. So if that's true, then, or if you have this, then this is the same thing as e to the 3x power times e to the c power. Would you agree with that? Because if I have this, then I would add them and I get to that, right? So e is a number. It's a constant. It's always 2.718, blah, 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 blah. So it's kind of like having 4 to the c power or whatever. It's still just some number. So then you can rewrite this as a times e to the 3x power, and then you've completely simplified what you have there. Okay, so you see how that works? I'm just going to kind of throw that out there because that was something that we had talked about before when we were talking about calculus stuff. All right, that's it. Your assignment is in Delta Math.